Hey everyone, thanks for joining us in another episode of Furuno's Making Waves podcast. I'm Jeff Kozlarek.
And I'm Eric Kunz.
And today we're going to be covering the DF3D Multibeam Sonar. But first, we have a special feature for you.
One of the great things about Furuno is our dedicated long-term employees. We really pride ourselves on them. And today we're going to actually take a little expose on one of those employees and let them talk about what they do here.
So stick around for the DF3D, but first, let's take a look at our first Furuno featured employee. All right, everybody, we're going to start with our first Furuno featured employee. And today we're going to be talking to Barb Curtis. She's our receptionist. She's the first person that you hear when you call into the building here. You know, one of the things that we're known for is our customer service, and it all starts with the first call. So here we go. We're going to come in here. We're going to talk to Barb.
Good morning, Furuno. How may I direct your call? One moment, please.
Hi, Barb.
Hi, Jeff.
Well, you are our first Furuno employee that we're going to feature here on the Making Waves podcast. So congratulations.
Yay, I'm the winner.
So Barb, how long have you been with Furuno now?
27 years.
27 years. So when Furuno moved from South San Francisco to here,
I was the voice that had the transfer over. We would switch between California and here because some of our people were still working in the California office until they moved up here.
So day one, you were here though?
Day one, I was sitting at at the cardboard table desk that they had for me.
So over the 27 years, you've seen and heard a lot here at the company.
Much more than I ever have wanted to.
Okay, so, but like a lot of the employees here, you started off, you were in the military, right?
Yes, I was in the Air Force and I served in Dover, Delaware on a C-5 Loadmaster.
Okay, and were you relocated in different spots?
I traveled out of Dover and I went to over 17 different countries, but we flew out of Dover and then would fly to Saudi Arabia, Turkey, Germany, Spain.
Wow, what was your favorite place?
Germany and Spain.
Germany and Spain. Did you speak the language at all?
Sprechen Deutsch ein klein bisschen.
That's more than I do.
But it was more because of the scenery. It reminded me so much of the Pacific Northwest with the mountains and the snow. I felt at home.
Wow. Well, it is a beautiful area here. So let me ask you this question. What is maybe the funniest phone call you've ever received here?
Well, it was actually not intentional phone call, and it's happened more than once. People will dial here for whatever, if they need some technical service or order something, and then they, in the call, put their phone in the pocket. And then they bend over and they redial. And I hang up and they redial again, and I hear conversations that I'm sure people really don't want me to hear.
The infamous butt dial, huh?
Oh, yes. And I've even had to call back the phone of some people and tell them that they keep redialing me.
Oh, that's funny.
Yeah.
So what is your favorite thing about working for Furuno?
The family feel.
The family.
I have worked here, like I said, for 27 years. It's lasted, some of my relationships here have lasted longer, marriages. But even though we may get angry with each other sometimes, we always seem to be able to work it out.
That's
and
awesome.
It is very much a family. If something's wrong, there's someone here who will help you.
That's very true.
Yeah.
That's very true. Well, great. Well, thank you so much. We appreciate it.
Well,
We're
it's
glad
an honor being on your first podcast.
Well, great. Well, thank you so much.
Oops. Good morning, Furuno. One moment, please.
Well, today we're going to cover, I think, which is probably your favorite subject, which is the DF3D Multibeam Sonar.
Yeah. The Multibeam is an amazing product. The DF3D has been around for about 5 or 6 years now. And the great thing about it is the ability to have a full 120-degree sweep under the bottom of the vessel. And not just have that sweep, but have it broken up into individual, like basically 43-degree beams, or 3 times 40 is 120. So you're getting that full sweep, but you're getting high resolution within that sweep, and you can tell where the fish are underneath the bottom of the vessel.
Right. So,
Yeah.
so we'll get into more of that in depth. But what I want to do is, I guess, first, just let's talk a little bit about what is the DFF3D and what's the difference between a regular fish finder, which is like a down transducer, versus a multi-beam sonar, and why would you have one over the other?
Yeah.
Or would you want both?
Well, it's great to have both because they, in a way, complement each other. The great thing about the DFF3D is that it's got multiple transmitters in it, unlike a single beam system, a single beam fish finder that's just transmitting one beam underneath the bottom of the vessel. The DFF3D consists of a black box system, which we need a little bit bigger processor because we have multiple transmitters. So this is actually the black box for the DFF3D, and it holds a lot of electronics in it. It's actually got 8 individual transmitters that allow us to drive each of these elements separately. There's 8 elements in the transducer, and then we phase them together and use math and trigonometry and things like that to create a full 120-degree sweep with about 3 degrees per channel.
So setup-wise, you need the DFF3D box.
Yes.
You need a transducer that plugs into it.
Yes.
And you need an MFD.
And MFD. Those are the 3 things.
So what MFDs does it work with?
Well, the nice thing is the DFF3D will work with any TZtouch2 MFD, any TZtouch3 MFD, and of course all the new TZtouchXL MFDs as well. So they're all designed to work with the DFF3D. You can actually have a mixed system, for example, with TZtouch3 and TZtouchXL as well. So it's actually pretty cool. You can actually have some maybe the newer charting technology on your XL MFD, yet you can still retain the TZtouch3 MFDs to run radar, regular sound, or DFF3D as well. So it's a nice to be able to kind of do a partial upgrade to get the full capabilities of XL and the existing capabilities of TZtouch3 and the DFF3D as well.
Okay. All right, great. So the box is this size, and that's really all you need to worry about with this. So I'm going to take this off so we can look at the MFD. But one of the things that you wanted to cover was the differences of an individual fish finder and a DFF3D. So. And in fact, we have some props, some arts and crafts.
Yeah, let's look at the real key to the DFF3D technology, and that is the actual beam pattern and the way we break up the beam. So let's look at the difference between the DFF3D beam pattern and a normal single element transducer beam pattern. With the DFF3D, we have these multiple elements which we can phase. In other words, we can time when the transmitter is basically triggered and when each element fires and create a steered beam pattern. That's the key technology of the DFF3D, and it was so revolutionary at the time, and why we've won so many awards with it, because it allows us to create this full 120-degree sweep, and we can break that 120 degrees into 40 individual 3-degree channels, for example.
So what are we looking at here with the different color beams?
Yellow, green, orange. These could be like a very wide, say a 45-degree beam pattern with the orange with a single transducer.
Like a regular fish finder.
Like a regular fish finder, exactly. Or maybe a little bit narrower green pattern or a narrow beam pattern with the yellow. But these are kind of what a single beam transducer and a single beam fish finder is capable of. The nice thing about the DFF3D and our phased array technology is that we can stretch that out and cover, instead of just maybe a maximum of 40 degrees on an ultra wide system, to about 120 degrees, which is 300% bigger. Basically, you're talking, 120 degrees versus 40 max, and we can chop that up to really get high resolution information out of the DFF3D. It's just not possible with other systems.
So how many beams do you have then that you're working with the multi-beam?
With the multi-beam, like I said, you basically have 40 3-degree beams that you're actually working with that we can actually create.
So port directly underneath and starboard?
Yes, exactly. So we break that up into 3-degree beams individually going 120 degrees underneath the vessel. The nice thing that does is it allows you to not just see fish off the port, center, or starboard, but it also allows us to create high-resolution PBG mapping with this DFF3D
And PBG
system.
is
Personal bathymetric generator. So you're creating your own personal bathymetric generated charts with the DFF3D anywhere you go in the world. You don't need charts if you're in, say, 300, 400, 500 feet of water to look at the bottom, when you can create your own charts, make a pass, have a nice wide coverage area, maybe a football field wide at a couple 100 feet. It's huge. And then, 50 yards or more, and then go back over it and look and see where the fish are that you passed over. So not only do you see bottom contours and you create PBG data, but you can see fish within the beam and come back and target those fish.
So with the PBG, you're creating the relief charts almost, where
Yes.
it's showing the bottom contour, or you're showing wrecks.
Yes.
Or you're showing whatever
Or
structure
fish,
might be.
exactly, or structure and fish together.
So
yes.
does that stay on your multifunction
The structure,
display?
exactly. The bottom structure will actually stay as you create that PBG data. But then as you come back around, you may see fish, or you may want to target fish either with the DFF3D or with your single beam sounder, come back over that same area, you go, oh my gosh, there's a big crevice right there. I bet you that's holding fish. And 9 times out of 10 it is. If you see a big cliff or a big piece of structure, usually places for fish to hide, come back around, basically look at the data with the PBG that you've created, maybe add more PBG, and then target those fish with your single beam
So
sounder.
you're basically like enhancing your charts real time with
Yes.
what's actually being seen underneath your...
You're enhancing and creating your own charts. That's the beauty of the DFF3D with PBG. You literally create your own maps anywhere you go in the world.
So and as far as how wide you can see and how deep you can see, I know it's 650 feet wide and 1,000 feet deep, but that's based on like water temperature and clarity. And that kind
Yeah,
of stuff,
there are
right?
some limitations, but typically you're going to get a minimum just about anywhere in the world of at least 500 feet roughly PBG data. You'll get 500 feet depth of PBG data, and that translates into a huge amount of area as you make just a couple passes back and forth. 600 feet, 600 feet, 600 feet when you're in 550 feet of water. That's a huge area that you can come back around, look at where the structure is, and then target that structure. So that's the beauty of the DFF3D. Now, the one thing that you have to understand is that I've heard people say, Eric, I don't like the fish target returns on the DFF3D. I don't get nice fish arcs. Well, that's because the DFF3D can't give you nice fish arcs. The reason is
that what this is?
Exactly. So every imaging transducer can be maybe wide in one dimension, but it's got to be narrow in another dimension. And that's why the DFF3D fore and aft beam width is only 7 degrees. That's what gives you the imaging capability. Right? So as you pass over fish, the fish aren't going to stay in the beam long enough to give you a nice fish arc. So the DFF3D just isn't designed to do that. A single beam transducer is. In fact, let's look at the beam pattern of a single beam conical transducer. Here's, say, a 25-degree beam out of a high-wide transducer, an Airmar high-wide, a chirp transducer. So if you have 25 degrees, as you pass over that fish, this distance off to the sides is what is going to give you the start of the fishtail. And as you go over the fish, it's going to get closer to the boat, which means that you're going to get that nice arc. And as you go over the fish, on the backside, this beam over here, which is kind of like the hypotenuse of a right triangle, right? It's going to be a longer distance. So that's what gives you the tailing fish.
And the traditional arch.
So the traditional arc is really not a fish. It's just this distance versus the center of the distance under the boat. When you're over the top of the fish, it's going to be closer. When the fish is off to the side, it's going to be further away. And that's what gives you that arc. It's all about timing when you're looking at that fish symbol, that arc on a wide beam transducer. Narrow beam transducers don't tend to do that because it's too narrow. The distance, this distance just isn't that much further than the distance underneath the bottom of the vessel.
So really, the best situation is to have both of these on your boat.
That's the beauty of the DFF3D and a bottom machine, a single channel or single frequency bottom machine, say a wide or a narrow. You can get the information from the DFF3D first on structure and then come back around and target that structure with the bottom machine, with your actual single element transducer, either wide or narrow, and use it in combination with the DFF3D. So in a way, they kind of complement each other. It's really nice to be able to use both of those pieces of information to really increase your situational awareness and really target the species and the fish that you're looking for.
Excellent. Well, that's a great description of this. Mm-hmm. So let's move on and let's talk about transducers a little bit.
Sure. So the DFF3D transducer, you can see that here's an actual single purpose or single function DFF3D transducer. If we look at the bottom, this was cast in clear resin, so you can actually see the transmitting elements directly on the screen. If we look closely, you can count right across here, there's 8 individual bars that are driven individually, unlike a single beam transducer, which may be conical or have maybe a rectangular pattern where you just have one element that you're driving. We drive 8 individual transducers with the DFF3D, and that's how we can steer a pattern underneath the vessel by changing the timing of these.
Thus multi-beam.
Yeah, he's multi-beam, exactly. So what we've done also, in addition to the single transducer DFF3D system, we've come up with some combo transducers as well. So if you don't want to put 3 or 4 holes in the bottom of your boat, you can just take a combo transducer. Here's an example of a combo transducer in a B260 housing that is has individual 5200 transmitter elements for the single beam system, as well as the DFF3D transmitter, as well as a temperature sensor. So you can see how we've stacked multi-functions, or multiple functions into a single housing. And the receiving and the transmit elements are far enough apart, 50 and 200 versus 165 kilohertz for the DFF3D. So there's very little interference between the systems, and you can save a lot of time and money by combining those functions into a single transducer.
So obviously these are thru-hulls.
Yes.
So we have thru-hull versions, we have transom mount.
We have transom mount versions as well of both single function and combo transducers as well.
And do we also have shoot through, or do we have those?
We don't really do a shoot through so much with the DFF3D. It really, because of the wide beam coverage,
so
you want an exposed transducer ideally with the DFF3D.
Okay. And also different makeup too of it. So bronze,
stainless, as well as plastic for the transom mount. So you have a choice there. Of course, stainless is great for aluminum hulls or even wood hulls, but bronze is perfect for wood hulls and fiberglass hulls as well. So really pretty flexible, and we have a wide selection, a lot of functionality, a lot of different power levels as well in the combo transducers. So there's a lot of different capabilities, a lot of sizes you can get.
So let's talk about the different modes within the DFF3D. So I see here that we have 4 modes here. What are the 4 different modes that we're looking at?
Yeah, these are the 4 modes that are available to look at and evaluate with the DFF3D on either TZtouch 2, 3, or XL. And let's go over each one. The 3D history mode is right here, and you can see I can actually change that around. Look at the 3D history, kind of a mapped short-term history of the DFF3D data. And you can see fish sign separated from the bottom with this, with a nice graph to show you both fish intensity or target intensity, as well as bottom height with that mode.
So what's the grid showing me?
The grid is just basically a reference. How far off to the port starboard and how far down the bottom is, and the fish sign.
So if I position it like that, you're telling me that this is showing fish off to the right side of the boat, this is fish off to the left side of the boat?
Yes, exactly. And that's the scale you're on. So as you change range, your scale will change. So you can look at, this is probably in meters, right, or feet, 20, 40, 60 feet. So it's fairly shallow water, but even in fairly shallow water, with the DFF3D 120-degree beam coverage, we can still cover a wide area with the DFF3D and actually get very high resolution. So as you see, as maybe a bottom or a wreck pops up, even in that shallow water, we can identify and see that it's just off to the right of the boat and it's holding fish around it. So it's pretty easy.
That's pretty cool.
There's also, on the lower left side, is a cross-sectional view. And cross-section is kind of a 2-dimensional view, just showing you as you pass over fish species or bottom or fish on the bottom, you can pick up that in real time. It's kind of like an A-scope mode, but in a cross-section of 120 degrees. So, and it shows you where the fish are relative to your own boat.
So explain to me what I'm seeing. So this is the bottom right here?
Yeah, that's the bottom. It's kind of curved a little bit because of temperature. Water temperature may change the speed, the propagation speed of sound in the water. So you can actually adjust this and flatten it out depending on water temperature. It's pretty easy to do. But once you make a setting typically for a season, you don't have to mess with it. And then once you have it flat, you can go over and pass over any structure or anywhere and look at what's happening directly in the vessel.
So here I'm looking at 60 feet is where it's showing the bottom,
Yes.
and then 60 feet is basically
Same
showing
thing.
right here.
Yeah, exactly.
Okay, and then these little targets in here are the fish that are showing up here?
Yes, exactly. But they're in kind of real time. There's no history, so it's wherever the transducer's passing over that 7-degree fore-aft beam is passing over these fish. You're going to see them, and then they're going to go away pretty quick.
Okay. But
Yeah.
0 is the center of the boat, and this
Yes.
is 20 feet
20
this
feet,
way and
40
20
feet. Yes,
Okay.
exactly. Yeah, so
All
that's
right.
what that represents. We can also take a more of a traditional bottom sounder image and use that with the DFF3D either in a single beam or a 3 individual beams. So this is like a triple beam, we call it. And this shows you basically what's under the starboard side of the boat, the middle of the boat, and the port side of the boat. So you can use it like a traditional bottom presentation and get much more information, 3 times, 300% more than you would with the typical bottom machine. So if you're targeting fish, you see them on the starboard side of the boat, you know to cast over that way. You know that's where they are.
Gotcha.
And that's the great thing about this presentation is that it's traditional, but it gives you a lot more information than a single beam sounder.
Okay.
And finally, we also have a side scan view that's available for the DFF3D. Arguably, it's not quite as popular because it doesn't really see into the bottom so much. The DFF3D is more of a traditional sounder where you're actually looking at the water column rather than into the bottom like you would with an actual side scan system. But it can be popular to use, especially in shallow water. So that's where the DFF3D side scan would come in.
But the nice thing is that it also works with our chirp side scan. So you can actually still have the chirp side scan, the 230
That's right.
kilohertz or
That's
455 kilohertz,
Exactly.
and display that here. So that will replace what the DFF3D is showing, but actually have the higher resolution like this is showing right here.
So the nice thing about any XL MFD especially is that you can have 4 individual presentations here. One could be your chart, your radar. One could be the bottom, the traditional built-in bottom fish finder, single element, the DFF3D, and the chirp side scan. So you can have 3 different sounder functions going on at the same time. Chirp side scan, DFF3D, and your single beam bottom machine all at the same time showing you different complementary information. That's really pretty nice.
What's nice too is obviously all the features that you normally use with the TZtouchXL or TZT3, like the 2-finger tap.
Yeah.
If you do that, it goes to a full screen, and you just tap it again, and it goes back to the 4-way split.
Or if you want to look at data, you can just easily swipe out. The whole thing with the TZtouch 2 or 3 or XL user interface is the swiping action. So swipe to open up things, swipe to close, swipe up to look at and adjust the individual screen that you're on, touch anywhere to get rid of it. It's really that simple, just like using your phone.
All right. You can set your favorite screen.
Exactly.
Easily
Set your
like
favorite
that.
screen just like that. So you just set that as a favorite screen, just like an old school radio.
And just, another thing too is what's nice with the XL is you have 10 different screen layouts that you want to do. So if you wanted to have your history mode, let's say, and the triple beam over here, and then have your fish finder down here, now you have all 3 of them right there, and you're able to see a full length of your fish finder and have everything else that you're looking for too.
Pretty cool.
Swipe down, boom, it's your favorite screen.
Save that one. Yeah, it's just that easy to use, and we can't say enough that we've compared the user interface of TZtouch with our competitors, and as we saw in Furuno Connections 2, we basically beat them to doing a lot of the different functions with fewer keystrokes, and just ease of use and simplicity is key.
All right, so one of the things that I wanted to cover, Eric, was to talk a little bit about what speed you need to be going for this. You have to go really slow to be able to do this, or how does this work on your boat?
Yeah, unlike a side scan system where you have to be moving slowly and at a constant speed, the DFF3D is not that sensitive, which is the beauty of it. You have those full 120-degree sweep with 40 individual beams, and it's transmitting at 165 kilohertz, so it's high frequency, not susceptible to a lot of noise at speed. So if your transducer in the DFF3D is mounted in a good place, you can be going 30, I've seen 40 knots plus, still getting pretty good bottom information, and been able to swipe across that whole 120 degree beam with 40 individual channels and look and see where fish are on the underneath.
And the PBG works at that same speed?
PBG typically works better when you're going a little bit slower than that, but just to use the DFF3D to target fish, to look for places where you might want to say, whoa, back off, let's circle back and let's do some PBG right in that area. I saw some fish sign. That's the beauty of the DFF3D, is that you can be going fast, see some fish sign, maybe correlate that to your single beam sounder at the same time, double back around, make a couple passes, and get a lot of information. Just find fish in places where you wouldn't normally be looking.
Well, and I remember one time we were out on a boat, and there was another boat that wasn't far away from us, and we had the DFF3D on our boat, and we could see a fish that was right off of their boat. We told them to cast out, and they were able to pick up that fish. Yeah. They couldn't see it on their fish finder because they didn't have the DFF3D. But what you're saying is exactly right. You can see fish where you don't normally know that they're there.
Right. Yeah. And once you see them off to the side, you know to double back around that way and then target that area. Make a couple passes. Collect some PBG data that'll be in your machine forever. You'll have that PBG data. You may find a new wreck. You may find new structure that holds fish that you just wouldn't see with a traditional single beam sounder. That's the beauty of the award-winning DFF3D technology and why it's so popular.
So the combination, DFF3D, regular chirp fish finder, that's the way you want to go, and that's going to give you everything you need to really hit your fishing adventure.
Perfectly complementary, a lot of information, super situational awareness for just about any fishing situation.
Fantastic. If you have any other questions about the DFF3D or fishing information just in general on our fish finders, feel free to post it in the comments section there, and we'll take a look at that and potentially have another podcast in the future that will cover the questions that you're asking.